Now let's talk about angles in the third quadrant. Now these are angles that 180 degree is less than them and they are less than 270 degree. Remember I have told you earlier that theta represents the particular angle we are required to find. Good. So can you think of an example of any number that is greater than 180 but less than 270? Now, just like the first set of questions I've given you, now these numbers, let us take 210 for instance. So let's assume that the angle we are required to find now is maybe sine 210. We are looking for the sine of 210 degree, the cosine of 210 degree, and the tangent of 210 degrees. So how do we find these three angles, which are the next three set of angles I gave us in the beginning? Now, if the angle we are given is a reflex angle, but particularly between 180 degree and 270 degree, we need to find the acute angle in this place, and that acute angle is going to be me taking away 180 degree from the total angle. Now let's assume now 210 degree is the angle that runs from here to this level. Now if I am interested in finding the little angle inside here, all I have to do is to take away the angle on the straight line, which is 180, away from it. And this is why I'm going to say that particular angle minus 180 degree. That will give me the acute angle for this side. And that is why you can see me write theta minus 180 degree. So which means if I'm required to find sine theta, where theta is the angle between 180 degree and 270 degree, then I can just check for the sine of theta minus 180 degree. So if I'm looking for the cosine of an angle between 180 and 360, all I can just check for is the cosine of theta minus 180 degree. And if I'm looking for the tangent of that angle, I just have to check for the tangent of theta minus 180 degree. But now that I've seen that, I can't just get them like that. I need to check what sign they are going to have inside here. Let us check for this angle. You are going to notice that the sign of this angle, the sign of this angle, the sign of this is going to be opposite over hypotenuse, which is negative y over 1. The opposite of this is this, negative y over 1, because this is the negative y axis. And I'm going to have a negative y. And by this is going to imply that what is here should be negative. Also, if I want to check for the cosine will be adjacent over hypotenuse. So the adjacent over hypotenuse is negative x over 1, and that will give me a negative x, which is a negative value. So here I'm writing a negative. Then lastly, what is going to be the last one, the tangent of this? We have that the tangent is opposite over adjacent, which is negative y over negative x. And you can see that this will cancel out, giving us a positive answer. So by this implies that what we are going to have here should be what? Should be positive. So it is going to be positive. Now at this junction, you can see that for all the angles in the third quadrant, sine is going to be a negative value. Cosine is going to be a negative value, but tangent will be a positive value. So if I'm required to find sine 210 using my four-figure table, what I'm going to have will be the negative of the sine of 210 minus 180 degree, which is the same thing as negative sine 30 degree. What about this? For angles that are greater than 180 but less than 270, for cosine, it is also negative based on what we have seen here. Then we are going to check the cosine of 210 degree minus 180 degree. and this is going to give us negative cos 30. And for the next one, tangent of 210. We have seen that in the third quadrant, the tangent is positive. So all I just have to check is the positive of tan 210 degree minus 180 degree. And this gives us the positive of tan 30. So which means if I'm looking for sine 210, I just have to check my mathematical table for the sine of 30 and add a negative sign to it. If I'm looking for the cosine of 210 degree, I just have to check for cos 30 using my mathematical table, then put a minus sign in the front. But for tan 210, I have seen that tan is positive in that particular quadrant. Then just check for the tan of 30 degree and attach your positive to it, and you get your final answer. So this is how you can check the values that are equivalent to this one using your 4-figure table. Now let's move on to the fourth quadrant. All right, welcome back. Now let's take a look at the fourth quadrant. Now this is the fourth quadrant. We have defined angles in the fourth quadrant to be angles that are greater than 270 here but lesser than 360 here. So we are talking about when they ask you to find the sine of 275, sine of 300, and so on and so forth. Now, or the tan of it, or the cos of those kind of angles. So this is an instance. We are looking for the sine of 310, the cosine of 310, and the tangent of 310. So how do we find this? Now, you know very well that that angle has to be the angle that has run from this place up to this level. Take for instance 310 degree. It has run from 0 degree to 180 to 270 and has entered this fourth quadrant. Now, if the level of that angle reached this place, then what is going to be the remaining angle inside there? You can see that it just remains a little to complete the 360 degree. Then for that reason, we can just take away that particular angle from 360 to get the acute angle of it. So which means that where my theta, where 270 degree is less than theta and theta is less than 360 degree, the sine of that angle will be equivalent to the sine of 360 degree minus that angle. The cosine of it will be equal to the cosine of 360 degree minus theta, and the tangent of it will be equal to the tangent of 360 degree minus theta. So now I just want to know what signs they would have, what kind of values they will have. Now for the first one, if we now pay attention to this particular angle, you will see that the sign is opposite over hypotenuse. So which is going to be negative y over what? Over 1. And that gives us a negative y. So it implies that the sine of this will be the negative of the acute angle we get from 360. What about the cosine? We know cosine is adjacent over hypotenuse. And you can see that our adjacent for this angle is what? Positive x. So we have plus x over 1. And that gives us a positive x. So which means our sine, our cos, our cosine is positive. Then for the last one, the tangent. The tangent is opposite over the adjacent. And that is negative y over positive x, and this is still going to give us a negative of y over x, and this is why our tangent is negative in that quadrant. So what have we seen? It implies now that if I'm required to find sine 310 degree, all I have to check for will be the negative of sine 360 degree minus 310 degree, and this will give me the negative of sine 50. So which means I can just check sine 50 and put a negative sign in the front to stand as sine 310. That is how I can find this angle using my mathematical table. For the next one, we have seen that cosine is positive. So that's going to be the positive of cos 360 degree minus 310 degree. And this will give us the positive of cos 50. So which means I can just check cos 50 to stand as cos 310. And lastly, what about tan 310? Tan 310 is going to be the negative of tan 360 degree minus theta, and this will give us the negative minus 310, and this will give us the negative of tan 50. So this is how we find angles between 0 degree and 360 degree. Now before we go, let's do a quick summary of what we have discovered in all these places. We have seen that for the first quadrant, all the trigonometrical ratios for angles between 0 and 90, all of them are positive. All are positive. All are positive. For the second quadrant, we found that it is only sine that is positive. Sine is positive. For the fourth quadrant, we find that it is a tangent that is positive. The tan is positive. And for the last quadrant, which is the fourth, we found that it is the cosine that is positive. For this reason, when you are asked to find any angle between the trigonometrical ratio of any angle between 0 and 90, all your answers will be positive, which you can check directly from your four-figure table. But for angles that are greater than 90 but less than 360, it is only the sine of those angles that are positive. The cosine of the angle that is greater than 90 but less than 360 is negative. The tangent of angles that are greater than 90 but less than 360 is also negative. And all you just have to check here is to check the equivalent of that 180 degree minus that angle. Do you see that now? So as I showed you earlier, we said sine 120 will be the positive of sine 180 minus 120. The cosine of 120 will be the negative of cos 180 minus 120. And the tangent of 120 will be the negative of tan 180 minus 120, which is 60. So that's how that is done. For the third quadrant, we find that it is only the tangent that is positive. And for the angle that you want to check, it has to be theta minus 180 degree. That is, take away 180 degree from that angle. So if you asked to find the sine of 257, just take away 180 from 257 and you get 77. So you check the sine of 77, the cos of 77, and the tangent of 77. Of all these three, it is only the tangent that will be positive. Now for the last one, the fourth quadrant, these are angles greater than 270 but less than 360 degree. We have learned that for this quadrant, it is only the cosine that is what? That is positive. So if you have this at the back of your mind, you'll be able to use your four-figure table to check for angles that are greater than 90 but less than 360 degree. Now, there is a portion of that question I gave you in the beginning. That is where we find the negative of trigonometrical ratio, the trigonometrical ratio of negative angles. How do we do this? Stay with me and let me show you how to do that.